All right, last problem in this section. Find the area of this shaded region. So what we've got here is a circle, and the radius of the circle is 2, and we're only looking at the region from 0 out to 1 here. So if we wanted to find the area of this region, first up, notice the circle is x squared plus y squared equals 4. So that means if we solve out for y, we get y equals the square root of 4 minus x squared. Now that only gives us the top half of the circle, but what I'm going to do is I'm just going to find the area of this bit here and multiply that by 4. So it's going to be 4 times the integral from 0 to 1 of this. And we've got to evaluate that. All right, so 4 minus x squared. That is constant minus a variable. So our a is going to be 2 and our u is x. So we're going to substitute u equals a sine theta. X equals 2 sine theta. And just because I always do, I'm going to move that over to the extreme left of the page. And then let's see, dx is going to be 2 cosine theta d theta. And my thing underneath the radical is going to be 4 minus 4 sine theta, or sine squared theta. So that's 2 cosine theta. I skipped a bunch of steps there, but you know, you can pull the 4 outside and you get a 2, and you're left with 1 minus sine squared, which is cosine squared. Take the square root, you got cosine. All right, so my integral becomes 4 integral, let's see, that becomes 2 cosine theta for the radical. The dx is another 2 cosine theta d theta. So we're left with, let's see, 4 times 2 is 16 integral of cosine squared theta d theta. All right, we need to deal with our endpoints, and we need to deal with this cosine squared. On this one, I think the endpoints are going to be nice. So let's try translating the endpoints. If we look at the top, x is 1. So you get 1 equals 2 sine theta. Sine theta is a half. And so theta is 30 degrees, but we have to put that in radians, so pi over 6. Then at the bottom, we got 0 equals 2 sine theta. So sine theta is 0. So theta is 0. All right, so our endpoints are 0 to pi over 6. All right, we've got to deal with that cosine. And remember, the way we deal with cosine is by using this formula here. I'm not sure if you can see it, but the double angle formula. So you get 16 times the integral of, let's see, 1/2. I'm actually going to put the 1/2 out front. 1 plus cosine 2x. That's what it says on my paper. But our variable here is theta, so we get 1 plus cosine 2 theta. We're going from 0 to pi over 6 d theta. All right, this is something we can integrate nicely. If you integrate 1, you get theta. If you integrate cosine, you get positive sine. 2 theta, we got to divide by 2. And we're going from 0 to pi over 6. So if you plug in the pi over 6, you get 8 times pi over 6 plus 1/2 sine of pi over 3. And if you plug in the 0, you get 8 times 0 plus 1/2 sine of 0. So this whole thing zeroes out. This one over here, though, let's see, what is sine of pi over 3? Think about that for a second. It's root 3 over 2. So root 3 over 2. For this, multiply it by that, you get root 3 over 4. So that's what I get for my exact answer. Now, I feel like checking this one with Desmos. So I'm going to go to Desmos and I'm just going to type in the integral that we started with. 4 times integral from 0 to 1 square root of 4 minus x squared dx. And it gives me a number, 7.65 blah, blah, blah. Is that what we're looking for? Well, what was the answer we got? We got this answer. Let's just type that in and see if that is the same. If I put in 8 times pi over 6 plus square root 3 over 2, it doesn't like it for some reason. I think maybe it doesn't like the square brackets. Let's see, I get that. Why is that? Oh, it's because I typed in square root of 3 over 2. It's supposed to be a 4. All right, much better. Now, you might ask, is this the only way to solve this problem? And the answer to that is no. It would be possible to solve this area without using calculus. If you wanted to, you could come up here and you could draw an arc up here and separate this area into these two places. This is a sector, and you could work out what fraction of the circle it is. I think it's 30 degrees. And you could figure out the area of this sector and the area of this triangle. Then add those together, multiply by 4, and you've got it. So you can do this without calculus. But there's another kind of famous problem that requires calculus that's very close to this. What if, instead of saying, what's the area of this part? There's kind of a famous problem that says, this circle here is a pizza, and you want to cut it into 3 pieces, where you want to cut it like this in 2 places, so that each one of these parts, here, here, and here, are equal. And how would you do that? And in order to set that up, what you wind up doing is setting up the same integral. But you don't know where to stop here. So you have to set it up so that the integral winds up being 1/3 of the pizza, or maybe it's a 1/6 because of the symmetry. Or it might even be a 12th. Yeah, but anyway, you need calculus for that problem. So anyway, that'll finish this section up.